You know that this acceleration is equal to 1 over 140 of g. And you know that the distance has to be measured from the center of the Earth to this location. So r equals r plus h. So radius of the Earth plus height. This is the equation you need to solve. You have two options now. Well, because you know g represents the acceleration on the surface. So you know this number, you know this. Now the mass of the Earth, here you need to be careful. I believe that if you look at the, I don't have it.
I have it as 6 times 10 to the 24th, but I don't know if that's correct.
You have to check. WebAssign uses a specific value for accuracy. And normally, if you go to WebAssign, and if you read the note at the top, it usually says, what value do you need to use? What part is it, number 2? Part 2?
Yes, problem set 2, number 2.
Part 2. So, mass of the Earth, 5.97 times 10 to the 24th kilograms. The radius of the Earth, 6.38 times 10 to the 6th meters. 1 year, 365.25 days. You have to use the numbers the WebAssign requires you to use. See? If you use a different number, even if your strategy is correct, the WebAssign will not like it. So there is another way to approach it, which sometimes gives a more accurate result. It doesn't really matter how you do it, you know, you can solve it. So it's 9.8 over 140 times g, oh no, divided. Actually, I want to flip it. So it's r plus h squared will be equal to gm over g times 140. And you can take a square root and calculate height. However, what we know also is that this g is supposed to be equal to what? Supposed to be equal to acceleration due to gravity on the surface when there is no height. This actually is a better way to do it. So you've got two simpler equations, and you can just divide, cancel g, cancel m, cancel big G. All you have to do is solve it using the radius. Well, the radius you have to use from the WebAssign. Okay, and that's it.
Thank you.
Sure. Okay, so she's left. Okay, next question, please. Yes, I'm listening.
Hi, can you hear me?
Barely, but yes, I can.
Is it better now?
Yes.
Okay. I just have a question on the homework part 3. Can I share my screen or?
Part 3.
Yeah.
Part 3.
Number.
Part 3.
Number 5.
Number 5, 4, 5.
5B.
The total pressure, you know what? I'm just gonna copy. Total pressure at cylindrical container. So we have a cylinder. And right here we've got total pressure. We know the area and the density of this. It's not water, it's something lighter because it's less. And this pressure is 105 kilopascals. Okay. The thing is, what people sometimes forget, this is the total pressure, not the gauge pressure. The total pressure is equal to atmospheric pressure plus the gauge pressure, which is density times G times height. So if you're looking for this, you have to take into account, which is 1.01 times 10 to the 5th pascals. Atmospheric pressure. So 115 kilo 000 equals 11000 plus your density. I don't know, well, your density is different, but G is the same times height. So you have to plug in your density and solve for height. And that's
Yeah,
part A.
I got the height, but I don't know how to do when I said
Let's
they
go
added.
to part B. So total pressure, if we have an additional amount, okay, an additional amount. So we had the same amount and now we are adding an additional amount. So you need again total pressure. So again, your total pressure will be equal to the atmospheric pressure, 101,000 plus density times 9.81 times new height. This is your new height. Of course, new height will be equal to the old height plus an additional height. So your goal now is to calculate that additional height. How would you do that?
I thought about finding the radius of the new cylinder. And,
Well, you already, oops, you already have the area. You know the area,
oh, right.
you know the volume, and you need to calculate that extra height. How do you do that?
Would we need the volume of the old cylinder or no?
Well, do you have a picture?
Yeah.
In your picture, this additional volume,
Oh. Okay.
do you have some kind of a
So
special symbol for that?
so we can find the height just from the volume equation because we don't know
Yes,
volume
exactly.
of the new.
That additional volume has to be equal to that additional height times the same area because it's a cylinder. You just need to pay attention to units.
Right. Oh, that makes a lot more sense. I
That's
also
it.
had a question on number 8.
Same part.
Number 8, part 3 as well.
I mean, homework. Ah, the last one. Water is flowing. All right. So, what is your question about this specific question?
So when we did like a similar problem during lecture,
Exactly.
the pressure was given, so we could like plug it in into the Bernoulli equation, and then the area times speed equation, and solve for the unknown. But like since we're not given P1 and P2, I don't know how to like approach the problem.
No, we have exactly same set of variables given to us. So let's see. You start from the ground level. And this is the radius number 1 given to us. And there is another horizontal pipe higher. And it is wider, like this. Higher by this amount and wider. And of course, these two pipes are supposed to be connected in a certain way, it doesn't really matter. And you see, it says calculate the volume flow rate. How do we do that? Area times speed. Where? Doesn't matter. Maybe at the bottom, maybe at the top. It has to be the same. So you pick. But of course, you have to calculate that speed, number 1 or number 2, because well, area is just pi r squared.
Yeah.
So you using a second equation, I believe you have pressure number 1, pressure number 2, right? The Bernoulli's equation, correct?
What would pressure number 2 be?
I'm not sure yet. I'm writing an equation. So until I finish writing an equation, I can't think about anything else. Now I can start thinking. So in this equation, what do you know?
H1 would be 0. So
We can set it to 0, absolutely right.
Yeah, and
Or
then H2 is 12.6, and so we know
all right, or else.
that. And then would P1 be like atmosphere pressure, or
No,
just
we don't know
0?
that. No, we don't know that.
And we know the density is 1,000 kilo over meters cubed.
Okay, what else do we know? If you still can't solve it, it means you're still missing some important information. Where can you find it? Where should you look for missing information? Where? In your cabinet? In your wallet? Where?
I'm not sure.
Well, if you don't know where to search, you don't search, and that's it. So you have to start searching somewhere. And what are your options?
Google.
Google or
A graph, maybe. Textbook.
Well, eventually, well, if you want to use Google, what question would you ask Google?
Like atmosphere pressure, maybe, or like how to calculate like pressure.
Okay, so your sticky point, you're stuck because of the pressure, right?
Uh-huh.
So go back to the problem and start reading it again, maybe word by word, because
Oh,
you,
it says that pressure is the same,
so
so
the
they
pressure
cancel.
is the same. So what does it mean?
Like they would cancel. Like P1 equals P2.
That's what it means.
Oh, I totally didn't read that part. Oops.
See, reading helps.
Yeah. Okay, that's so much easier. And then I can
Of
solve
course,
for P1.
and the rest is just pure, well,
Mm-hmm.
algebra, a little bit of algebra. You don't even need density, I believe, because now you can cancel density as well.
Mm-hmm.
Well, the rest is algebra. You have to solve two equations. This is the first equation, and a second equation, V1 squared over 2 equals GH2 plus V2 squared over 2. So, well, that's math.
Mm-hmm. Okay.
If you
Yeah,
do it,
I think I got it now.
yep,
Thank you.
okay, sure.